Hi Mobiconf, my name is Katarina Sheremet. I am founder and mobile developer at the Learn Flashcards, and I am also Google developer expert in Flutter and Dart. And today I'll talk about state management in Flutter apps, exactly about BLoC. Please raise your hand who know what Flutter is. Great, and who tried to create a Flutter app? And who used state management? And who used BLoC? It's good to see that some people used BLoC. And today I'll start my presentation with a short introduction what Flutter is. And after that, we'll learn about BLoC and see an implementation of BLoC in Flutter Hello World app. And after that, we have a look on some cases of implementation BLoC in non-trivial app. And let's start with Flutter. Flutter is Google's UI toolkit for building beautiful, natively compiled application for mobile, desktop, and web, and from single code base. And it's free and open source. Widgets are the basic building blocks of Flutter app. Widget can be a structural element like button or menu, a stylistic element like color, scheme, or fonts, an aspect of layout like padding. Even the whole app is a widget. Everything in Flutter is a widget. And that's it with Flutter introduction. And let's jump to main topic of my talk. It's a BLoC with a complex architecture. And complex architecture may include validations, persistence, error handling, and a large amount of data. Let's start with history of BLoC. BLoC stands for Business Logic Component and was presented by Google at DartConf 2018. It was designed to allow the reuse of the same code base independently of the platform, mobile, web, or desktop. And to implement BLoC, we need to know such terms as stream, sink, StreamController, and stream builder. Stream is a continuous flow of data. It has a single direction. You can only read from stream. You cannot write to it. Sink takes an input. You can only write to sink. You cannot read from it. And sinks and streams come in pair. When you write to sink, it creates an event in stream. And to create a sink-stream pair, we can use StreamController class. To create sink, we call property sink in StreamController class, and to create stream, we call property stream. And sinks and streams are also typed. Here is how a diagram looks like. We create a pair using StreamController, and we have a sink to write to one side of the pipe, and a stream to read from another side of the pipe. And there is also an additional pipe for errors. We use Stream Builder to get updates on the UI. Stream Builder has stream parameter, where we assign our stream, and it has snapshot, and when new snapshot arrives, widget get rebuilt. And snapshot is the latest state of stream. And BLoC is a view model MVVM. So BLoC is a view model in MVVM application. MVVM is an architecture pattern, and it stands for model, view, view model. Model saves data to storage and contains some storage-specific API calls. View is a UI, Flutter or Angular Dart, if you prefer create web with Angular Dart. And view model is a BLoC. And BLoC has some strict rules. BLoC is a class. The only interface it has, sinks and streams. Sinks, it's input, and streams, it's UI modifiers or comments. It means no fields, no methods, no setters, and dependencies must be injectable and platform agnostic. And it means that you cannot say if platform is Android, do this. If iOS or web, do that. It won't work like this. And data flows from the UI to BLoC, from BLoC to the UI, using simple streams and sinks. Simple means you cannot use platform-dependent constructions. And there are some rules for the UI as well. Each complex enough component has a corresponding block. And components should send data as is. For example, we have text field where user types some data, and we send it as it is. We don't change it because it's already a business logic. And when BLoC is making change to UI, it should be as close as possible to the outputs we are aiming to show. Every modification and change should happen in business logic. To have the whole picture, let's see how BLoC can be implemented in Flutter Hello World app. Flutter Hello World app has increment button, input, and has counter text. It displays how many times we tapped increment button. We have add BLoC class that has sink on add, our input for increment button, and it has stream do set result. It's our output for counter text. And in constructor, we are listening for the input event when button is pressed. And when it happens, we increment counter value and put it in do set result stream using controller. And on the UI, we have button that fires the input event. And to get updates, we use stream builder, and we assign do set result stream to stream parameter. And when new snapshot arrives, our text widget gets rebuilt every time, and we can see the new value of counter. Now let's implement BLoC in non-trivial app. I've decided to take a dictionary app as an example. Let's have two screens, a list of vocabulary and add update screen. For readability in my example, I've decided to use the following naming scheme. When event is coming from BLoC, from view to BLoC, for example, on when back button is pressed, sink has on prefix, for example, on back pressed. And when BLoC is making change to UI, stream has do prefix, such as do pop or do show validation result. I like starting my development from end result. Let's start with the view. The first question, how do you initialize your view model? With BLoC, view does not populate any of its fields, no methods, no setters, and BLoC has to send initial data to view over Sink+Stream pair, and view has to read it from stream. We can create a stream for every field to set them separately, or we can use a composite object to set them all at once. But composite object has some cons. It needs to be composed in model. It needs to be composed in BLoC, sometimes from multiple models, and it needs to be decomposed in view. And imagine a situation where you have your first widget that was modified by user and another one not. But the second widget still will be rebuilt because of a new snapshot. Therefore, we have a sink and a stream pair in dictionary app, and we have on word and on translation sinks as inputs for text field, and do word init and do translation init as outputs to initialize fields. And on the UI, word and translation have text edited controllers, which are initialized in init state callback. And for this, we listen do word init and do translation init streams. And when new data arrives, we assign it to our controllers. These controllers are assigned to text fields, because text field has controller parameter. And when data was changed by user, we send it to BLoC by writing it on text or on translation sinks. And we have already at least 2 streams and 2 sinks exposed from BLoC. Let's talk about validation. When we create a word with translation, we still need to validate that fields are not empty, and depending on it, enable or disable save button. And validation happens in business logic. To provide live experience, we can run validation on every user input event. For example, text field, checkbox, and slider. And we have to show validation errors as well. For this, we can create streams for every field, or we can use existing one and send validation error events to them. After that, we will be talking about dirty bit. Dirty bit is a concept when the object was changed from what it was at the beginning. And BLoC is in a much better position to keep track of this bit, since it knows which fields are validating, which UI elements are validating data, and it has an initial data to compare to. Therefore, dirty bit belongs to business logic. Let's talk about back button. Back button handled by scaffold. Scaffold is a widget that implements the basic material design layout structure. And this class provides API to show snack bars, up bars, drawers, etc. To add business logic when user pressed the back button, we need to wrap our scaffold widget with willPop scope widget and implement on willPop callback. On willPop callback must return true or false. When we return true, the current screen will be closed, otherwise not. And the easy mistake to make here is to prevent user from going back. For example, when validation fails. Let's see how it can happen. We can go 2 ways from here. One is to silently autosave when user presses the back button, and another one is to show confirmation dialog. Let's consider the autosave scenario. To handle autosaving, you can tell BLoC to save information by writing it to sink on save. And after that, we immediately return false to not close the screen. In happy autosave scenario, BLoC tries to save the data and tells view to close the screen. Here is how the flow looks like in the code. The view pings BLoC by sending empty data over Sink+Stream pair and immediately cancels the close event. And BLoC tries to save the data and pings view back to close the screen. But if validation does not pass, it generates an error to show to user, and we cannot leave the screen. Saving to database can sometimes fail as well, and user is trapped, and user cannot leave the screen. Because of the trap, it's a bad user experience. Another way is to show a confirmation dialog, where the user wants to save changes. The same story with willPop scope, but BLoC tells the view to show confirmation dialog if data was changed, because BLoC keeps track of this dirty bit. And to implement this business logic, we need at least 1 sink that user leaves the screen and 2 streams. One is to show confirmation dialog, and another one is to leave the screen. What about saving data? If there are no validation errors, user presses save button, and view tells BLoC to save the data by writing it to sink. BLoC tries to save the data, and if it fails, it shows an error to user. And if everything goes well, can't we just leave the screen as we did this with the back button? Not necessarily. When we add word with translation to a dictionary, we shouldn't leave the screen. Probably user wants to add more vocabulary, and for this we need an extra stream to clear input fields and to set input focus to the first field. Another problem is that saving data can take a little bit longer. And during this time, we should disable Save button and show confirmation dialog to make sure that user doesn't save hundreds of objects by smashing the Save button. And to implement this business logic, we need one Sink, Save button, and about 2 to 5 streams. Show error, close screen, clean fields, show progress indicator, and show confirmation dialog. Let's talk about validation. In Vue, we show localized buttons, hints, etc. We also need localization in BLoC because we need to generate localized validation errors and confirmation dialogs, and localization can be changed in runtime. Therefore, we need extra Sink to update our localized messages about validation and errors. Let's count how many pipes we need to save a word in dictionary. In general case, we need 7 on save, do pop, on pop, do show error, do show confirmation dialog, on localization changed, do show progress bar. And to add word, we need more. We need 5 more. And why not just one dynamically typed stream? Dynamic means any type. Any type. Well, this is a viable approach that has some cons and pros. Pros, we don't need to dispose a lot of Sink+Stream pairs. And cons, losing the benefits of statically typed language. It's easy to forget to handle a specific type or to handle the type that no more exist. And it feels like re-implementing a type system. Anyway, BLoC is easy testable, no dependencies in Flutter, and pure Dart. We don't need to use slow and hungry emulator, and it's faster on CI, and you just need to swap your models with the mock implementation. And Dart testing framework supports async tests. And that's it for my presentation. If you have questions, you can ask.